In the previous video, we've expanded a plus b to the fourth power by using this traditional binomial theorem. And in this video, we're going to look at the same thing, but from a different viewpoint, which is the Pascal's triangle. So, first what you need to do in a Pascal's triangle is to set up that triangle. And to do that, you put a base of this 3, 1. And this is the first line, and this is the second line. And the next line will be a term in the middle of two terms, every two terms, and the result would be their summation. Here is 1, and here is also 1. And the total of these two are not the proper way to explain this Pascal's triangle. The proper way to explain this is to say how many ways you can get to that term. So to get in this term, you got only one way, which is in this direction. But to get to this term, you have two ways, which is you go from this direction and you can also go from this direction. So there are three ways by which you can get here, three ways to get here, one way to get here, just this, and one way to get here. And this is the fifth line, and this is what we really care about when we are expanding something to the fourth level, because it's when n equals 4. There are 6 ways to get here, 4 ways to get here, and just one way to get here. So this is the expansion of something which is expanded to the power 0. And if something is expanded to the power 1, this is the coefficients I'll claim. And if something is expanded to the power 2, these are the coefficients. If something is cubed, these are the coefficients. And if something is raised to the power 4, these are the coefficients. So in our case, we're doing a plus b to the fourth power. Now, how to do this, right? So first, let's have a look at this. The first coefficient should be 1, and every time the first term is started from the highest power and the second term is started from the lowest power. So a to the power 4 and b to the power 0, which is 1, and the coefficient is also 1. So a to the power 4, and here the coefficient should be 4. The triangle says so 4, and every time in every step the first term's power will increase by 1, so a cubed, and here the second term's power will increase by 1. So here is b, here was b to the power 0, so here is just b to the power 1. And the next coefficient will be 6, and so a to the power, here is a squared, and plus 1 is b squared, plus here says the coefficient should be 4, and so here will be 4, and a to the power 1 because it will decrease, and b cubed, and here it says the coefficient is 1, so it's just b to the power 4, and a to the power 0 is also 1, so it's just b to the power 4. Now notice that these two are the exact same. Now the question is, why did it work? Why did this triangle work? Actually, when I was saying there are like 6 ways to get here, 3 ways to get here, let's see what this actually means. So let's say a plus b whole squared. So this will be a squared plus, so the coefficient is 2, and s bar will be decreased by 1, and b will be increased by 1, and b squared. So here look, how many ways can you get this a squared? That is what the coefficient mentions. So a plus b whole squared is a plus b into a plus b, right? So there's just one way you can get a plus b, I mean a squared, which is multiplying these two a's. There's no other way, right? So there's just one way of getting this a squared, so the coefficient is 1. And if you look for the b squared, it's the same as well. You just multiply b with b. No other way of getting the b squared. So there's just one way to get the b squared as well. But why is there 2ab? The coefficient is 2. Why? Because you get ab in two different ways. Like you multiply this a with this b, and you also get ab by multiplying this b with that a, right? So there's two way, and that's what the Pascal's triangle mainly describes. So here is ab plus ab, which is 2ab. Hopefully the video was helpful. See you in the next video.